Assalamu alaikum. I'm sorry, I'm still setting up. These things are not easy to do, but anyway, here we go. Assalamu alaikum once again. I would like us to start from where we were the last time. Anyway, so this is the third week of the emergency teaching. Okay. And I'd like us to continue with section 17.2, 17.3, 17.4. In these three sections, we shall look at, last week we introduced the concept of complex numbers, where we are here, complex numbers. We'd like to say more things. Once you introduce numbers, like you did in real number case, you brought in the issue of sets, and then you relate sets to another set, then you call that, functions. And then the moment you bring in functions, you can bring in the concept of limits, continuity, differentiability. That's now for real numbers. For complex numbers, you talk of analyticity or analytic functions, okay? Anyway, let's continue. So the first thing I would like to remind you is what? Last time we were looking at a complex number Z in C is expressed algebraically as Z equals X plus IY. Now we can express, now X and Y, we think of X, Y, those are rectangular coordinates. Then we can also express the same, points or numbers in polar form. Polar form means that if we have this as the origin, this is theta, an angle theta, this is X, this is Y, so then P, a point P, is expressed in terms of X coordinate, Y coordinate. That's a rectangular form. And then we can also think of it in terms of the polar form. Polar form would be theta, then you have R, so this would be R theta, okay? So we have a way of going from rectangular to polar to rectangular form, which is this, that X equals R cos theta, the cosine of this angle would be X over R, so X is R cos theta. The sine of this angle would be Y over R, so Y would be R sin theta. And by Pythagoras theorem, R would be X squared plus Y squared square root. And then the tangent of this angle would be Y over X. So you can move from polar to rectangular, rectangular to polar form. Okay, ladies and gentlemen. Polar form. So for any complex number Z, we can express it in polar form this way, which comes from, you come from X plus IY to R cos theta plus I sin theta. We can simply write as R E, this is E, I E theta. Now, definition. If you have a complex number in this algebraic form, we can express it in polar form this way, because we already have this definition here. And so we can write it in this term, that X is R cos theta and Y is R sin theta. And this cos theta plus I sin theta is actually E I theta. And our angle theta is periodic. Periodic means that, if you have an angle, normally we usually go this direction. We measure angles anti-clockwise, that's positive direction, negative direction this way. So if it's, when theta, when K is 1 or K is 0, you are at theta. When K is 1, you just, at the same angle, then you go around anti-clockwise, you come back to the same angle. So it's just the same. Or if K is minus 1, you go back the negative direction this way, you come back to the same angle. So this is periodicity of theta. And so the angle theta is called the argument of Z. And so the argument, because of this, actually has many values. Okay? Actually, we can say infinitely many values. So we do have a unique value of theta that lies between minus pi and pi. And so for such a value, we call it the principal argument of Z, the complex number Z. The first example number 1, express Z equals 1 minus I root 3 in polar form. So what do we have? Well, here we do have X is 1 and Y is minus root 3. So that means our R will be this squared plus this squared. So it's just 1 plus 3 square root, which will be 2. Then theta would be, theta, like I told you already previously here, that theta is tan inverse of Y over X. And in our case here, we do have our tan inverse of root 3 over 1, which is minus root 3, sorry, minus root 3. And so minus root 3, ladies and gentlemen, will be minus pi over 3, if you were to measure. How do we think of that? Well, we think of it this way. If I take you back again, minus is 1, x is 1, and then minus root 3, y is somewhere down here. So the angle is somewhere here, so you are measuring this direction. That's what you have. And so, and then minus pi over 3 is actually minus 60 degrees, which lies between minus pi and pi. So actually this would be the principal argument. And so we can express our z, which was in rectangular form, in polar form this way. That z is 2, the radius, cos minus pi over 3 plus I sin minus pi over 3. That's it. Operations in polar form: multiplication, modulus, and argument. So multiplication, when you have two complex numbers in polar form, then you can simply multiply like this. Z1 times Z2 will be, well, the first one times the second one. Now here I've written it in this form. And actually this is the same as if I just multiply this by this. What do I get? R1 times R2, then cos theta 1 times cos theta 2 minus sin theta 1 sin theta 2. That would be actually, well, this trigonometric identity, that cos theta 1 plus theta 2, if you expand, this will be cos theta 1 cos theta 2 minus sin theta 1 sin theta 2, which is what you obtain there. And then this one will be obtained from these others, that cos theta 1 times sin theta 2, then sin theta 1 times cos theta 2 would give you that. And so basically Z1 times Z2 would just be R1, R2, you multiply the radius or radii, and then you add the angle. And then for the quotient, Z1 divided by Z2 would just be the radius divided by the second radius, and then you take the difference of the two angles. That's it. Modulus, well, this is straightforward, that the modulus of two complex numbers is the same as the modulus of the individual complex numbers multiplied. And the quotient likewise, that if you take the modulus of the quotient of Z1 and Z2 is the same as taking the modulus of the quotient of Z1 divided by the modulus of the quotient, of Z2. When you divide the numbers, the same thing used to happen for any number, so I don't need to say much. Then this one follows from here, that the argument of Z1, Z2, when I have a Z1 and Z2, so the argument of the product will actually be the sum of the argument of Z1 and the argument of Z2. That's why we have this. And then the quotient, the argument of the quotient would actually be, again, this one. It's just the argument of this is theta 1, the argument of this is theta 2, so you just subtract. And that's it, ladies and gentlemen. Next, example. Given Z1 equals I, and Z2 equals 1 minus I root 3, determine Z1, the product, the quotient, the argument of the product, and the argument of the quotient. So, the argument of the product, we say the argument of the product, we can just multiply simply. Of course, if you ask to in polar form, you need to convert this to polar form. But anyway, so Z1 times Z2 is just this times this, we just give you I times 1 minus I root 3. So, I times this will give you minus I squared root 3, but minus I squared minus, I squared is minus 1 times this minus gives you plus root 3, and then this is I. Finish. Then Z1 divided by Z2, this we did previously. You just take a complex number divided by another complex number. The same as a complex number, you multiply by the quotient of this and divide by the same quotient. And this will give you numerator. This will be minus root 3 plus I. And then this will be 1 plus 3, which will be 4. That's it, ladies and gentlemen. Then now we go to these two parts. Now, for Z1 equals I, and Z2 equals 1 minus I root 3, we need this and we need this. So, solution, we need the argument of Z1. Now, what's the argument of this? Well, the argument of this number Z1 is the same as, you can think of it as 0. The real part of this is 0, plus I. So if I'm looking for the argument, remember what we're doing for argument. We need theta. And for theta comes from y, which will be 1 over 0. That will be infinity. Which means that tan theta equals infinity, which is basically sine is 1, cosine is 0. When does that happen? When it is 90 degrees. The sine of 90 degrees, or pi over 2, is 1. And the cos of pi over 2, or 90 degrees, is 0. So that turns out to be pi over 2. The argument of Z1 is pi over 2. Then the argument of Z2, this we did from previous example, is minus pi over 3. So we have the argument of z1, z2 will just be the argument of z1 plus the argument of z2. So it's just this plus this, which gives you pi over 6. And then the argument of the quotient will just be a difference. So it's pi over 2 minus pi over 3, which would give you that. And that's it, ladies and gentlemen. Okay? Next, power of z. Okay? Let's see how much we can push this video. So, powers of z. What were we talking about? Given a complex number in algebraic form or in polar form, then we have two definitions here. Actually, I could call it definitions. That z power n, of course, here you can expand this binomially, this algebraic. Or you can just simply say this is power n, so it will be r power n, and this will just be e I n theta, which we can write in this form. This is r n, but then this should be n here. This is an error. So r power n, then this would be cos n theta plus I sin n theta. And that comes from this. This is called the Moivre's theorem, that when you have cos theta plus I sin theta raised to power n, is simply multiply the angle. It's cos n theta plus I sin n theta. Okay? Now, are we able to do the example? Yes, maybe we can. So, example number 3. Compute z cubed, given that z equals 1 minus I root 3. Our solution here, we already represented this in polar form. So the first thing is to convert it to polar form, which we did. So we have z is 2 cos minus pi over 3 plus I sin minus pi over 3. So z cubed will be, you cube this, you get 2 cubed, which is 8. Then cos minus pi over 3 plus I sin minus pi over 3 cubed. You apply the Moivre's theorem, you just cancel out. So you multiply the angle by 3, the angle by 3. You get 8 cos minus pi, these 3 cancels. I plus I sin, this cancel, so minus pi. And then, now, we are looking at pi. So this one would be 0. If you punch in your calculator, you get 0. I mean, the sign of minus pi is 0. The sign of minus pi would be minus 1. So minus 1 times 8 is minus 8. And that's it, ladies and gentlemen. Please check that. And that's it. Okay, so this will start in the next video. So you're welcome. I mean, I hope you understand, you follow. Any questions, please ask. Do not hesitate. Okay, bye-bye for now.